Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we'll be looking at algebra revision. The two subtopics that we're going to be doing in algebra, algebra will be the nature of roots, which contributes about five marks. But we know it is a bit of a challenge to the learners, and we want you to get these marks. And also the complex numbers, which is about 15 marks. So all in all, we'll be doing about 20 marks, which is a lot. And these are the marks that you need to get. Every one of you must get these marks. The nature of the roots, by the end of this lesson, this is what we must be able to do. We must be able to determine the nature of the roots without solving the equation. And this is a very important part here that says without solving the equation. Because mostly we know, once we say without solving the equation, now you guys think that we're just writing them down without writing something. We need to determine the nature of the roots by using a formula. And that formula is the one that we get that we get in the quadratic formula. So I'm going to put the quadratic formula here, which is x equals to minus b. You don't have to memorize this, it's there in the formula sheet, plus minus the square root of b squared minus 4ac all over 2a. So now what informs the nature of the roots? So what informs, when you say determine the nature of the roots without solving the equation, you'll see what we're talking about. We're talking about that formula that is there inside the square root. So I'll show you in the next slide what we're talking about. The next thing there that you need to know is to solve a variable when the nature of the roots is given. So if I'm given that the roots are real, rational, or equal, how do I then solve a variable that is in that particular equation that has been given? So those are the two things that we're going to be looking at in these questions. Now, if you look at the notes on this content, this table is very important. Now look at what I was talking about. The formula that we're going to use for determining the nature of the roots, what type of answers are we going to have? The answers will be determined by what is inside the square root. Now look at this. This is called delta. So it's called delta equals to b squared minus 4ac. I've seen in some of the question papers, they'll ask you, determine the value of delta, or determine delta. Or they'll say, determine the discriminant. So please, these are discriminant. So these are the terms that are going to be used in an exam. Sometimes they'll say, determine delta. So the delta is this sign here, and it represented by that. So which means that I really need to work out something in order for me to get the nature of the roots. Now remember, a is the coefficient of x squared. So in other words, your equation must be in the form ax squared plus bx plus c, where a is the number that is next to x squared, b is the number that is next to x, and c is the constant. So if I've got a, b, and c, I can be able to substitute them there. Can you see it's a, there's a b, there's a c. So the nature of the roots will only work when we have a quadratic equation. So in this quadratic expression, I'm going to write this equals to 0 to make it an equation. So if this part is not there, which means that the b value will be 0. If that part is not there, it means that there the c value will be 0. So, but we are going to work where we have an x squared. The x squared must be there. Now, look at this. the value of delta and the description of the roots. This is the table, very important table that you must learn. If you know this table, there will not be any problem in terms of this question. Now look at this. The delta value here and the description of the roots. So let's look. When delta is equals to 0, in other words, what I get inside the square root, it's equals to 0. Therefore, the type of roots that we're going to have will be real, it will be rational, it will be equal. So the type of roots that I'll get when the delta is 0 will be real, rational, and equal. So if you work out on a sum, then you find that the two answers that you are getting are the same. Therefore, it means that the roots, the roots they are real and rational, and they're also equal. The most important part here is the rational and equal, because we'll be in the nature of the roots, we're dealing with real and unreal roots. Now, when delta is greater than 0 and it's a perfect square, what does this mean? It means that if what is inside the square root, it's greater than 0, the value is bigger than 0, and it is also a perfect square. What do you know about perfect squares? You know, those numbers like 1, where we can get the square root. So these numbers are perfect squares. 1 is a perfect square. Why? We can get the square root of 1. Square root of 1 will be 1. 4 is a square root. It's a perfect square. Square root of 4 is 2. But 5, it's not a perfect square. So therefore, those numbers that we can get the square root of, so those are perfect squares. So for instance, if I've got 121, I know that the square root of 121 is 11. So this is a perfect square. So if the number that is inside the square root, or when I get, when I substitute there, and the answer that I get there is 121. Therefore, I know that it is a perfect square. Don't have to put it inside the square root. Just check if that number is a perfect square, and we must be able to get that answer then. So which means that what type of roots am I going to get? I'm going to get real roots, I'm going to get rational roots, and I'm going to get unequal roots. That should be unequal roots. Right. They're not going to be equal. The roots are only going to be equal when they real and if delta is equals to 0. If delta is not equals to 0, the roots will never be equal. So it will be unequal there. Right. So now, what happens when the delta is still greater than 0? But that delta that we're talking about is not a perfect square. Like for instance, square root of 5, like square root of 12, those are not perfect squares. So if they're not perfect squares, what type of roots will we have? We'll have, they're still going to be real, they're still going to be irrational, they're going to be unequal. So they're going to be irrational. You see, the difference between the two is that with rational roots, perfect squares. With irrational roots, not a perfect square. Both will be unequal. Unequal means the other one might be 2, the other one might be 3. So the answers that I'm going to get, remember when I use my fully quadratic equation, either the answer will be real or, it's either we're going to have 2 answers or we're going to have 2 equal answers or 2 unequal answers. When do I get equal answers? When delta is 0. When do I get unequal answers? When delta is greater than 0. The other one will be perfect squares. The other one will be not a perfect square. Not a perfect square, irrational. Perfect square, rational. Now, when the delta is greater or equals to 0. So remember, if it's greater or equals to 0, then we have a combination of these two. We're going to have real roots. So either the roots can be irrational or the roots can be rational, correct? Because we are combining all this. Or sometimes you can find that if it's equals to 0, that will be real, rational, and equal. But everything there will be real. Can you see it's real, real, real? Because it's greater than or equals to. Right. Let's check that last one, which is also very, very, very important. You must note this, that when delta is less than 0, then the roots are non-real or unreal roots. Remember, that is when you have delta less than maybe the delta, when you substitute there, we get a negative number. Then we say then the roots are non-real. Remember, these are complex numbers. That is why we combine these two sections, because they talk to each other. I know that if it's negative square root of a negative 9, then I've got non-real roots, but I can use complex numbers to get to my answers, which will definitely have an I. Okay, when you get to this section, then we'll do that. I'll show you how we do that. All right, I think I've explained this, and then we really need to understand this table. So this table is very, very, very important. So when you study practicing your nature of the roots, you must have this table next to you, and you can answer any question that talks to this. Right. Now let's look at the first activity. Now, if I'm given f of x, it's equals to 15 over x squared minus 4. See, now here, I need to understand the roots. I need to understand what is undefined. I need to understand how do I get the nature of the roots in this one also. Now look at this. It says, for which values of x is f of x? So f of x is that whole thing here. When will it be undefined? So we need to understand what undefined means. Remember the square root of minus 9. It's defined. It's defined by complex numbers. But when we talk about undefined, something that is not going to, that we need to put, any value that we must put on the x, that will make this whole thing to be undefined. Now, what is undefined? That's very important to understand. What is undefined? Now, if I take my calculator and say 2 divided by 0, for instance, and 2 divided by 0 on my calculator gives me an error. Now, that error is undefined. But if you still take the same calculator and say square root of negative 9, it will still give you an error. But that error, when we are talking negative numbers inside the square root, we know how to do it by using complex numbers. The only thing that we do not know how to do by using complex numbers is when we have a number divided by 0. So in those identities that we have, it's one of the identities that we have that a number divided by 0, it's undefined. So if I've got it 5 and I divide it by 0, that becomes undefined. We cannot define this. It does not make sense to us that we can take something 5, a number, and divide it by a 0. Okay, so that is undefined. But if I've got the square root of a negative 5, it's a complex number, a non-real number, but we can work with it. But when we talk division by 0, totally, that will be undefined. Right. Again, if I take my calculator and put it and say 0 to the power of 0. If I say 0 to the power of 0, that's something that is also, and we cannot define it, okay? Remember, in exponents, we tell you that, you tell us that any number raised to the power of 0, it's 1. But if you take your calculator and say 0 to the power of 0, then you get an error. So except 0. So we must be careful on that. So in this case, what do? We will say the 15 cannot be divided by 0. But which numbers must I put on x to make this whole thing to be 0? So which means I must then say this value here equals to 0. That will make the whole thing to be undefined. So I'll take my denominator, x squared minus 4, and I say equals to 0. Now remember, if that can give me 0, it means that the whole thing is undefined. So that is what we are looking for. X values, we should make that whole thing to be undefined. So then I can factorize this, x and x, 2 and 2, a minus and a plus, which then gives me x equals to 2, or x will be equals to negative 2. So which means, if I put x to be 2 here, 2 squared is 4, 4 minus 4 is 0. Then if this whole thing is 0, then it becomes undefined. That question is very important. Most question papers it is there where you need to define the part. Now, in this case, then I can then say, for undefined situation, my x will be equals to 2, and the x will be equals to negative 2. This is when this whole thing will be undefined. So it will be undefined when x is 2 or x is minus 2. That's when it is undefined, because they need the values of x for which will make that whole thing to be equals to 2. Why the 3 marks? It is because you still need to substitute to equate that to a 0. And the other 2 marks will be for the answer. All right. Next question. Now, one thing that we need to look at when we are revising, it's to read the question and understand. You can read it 5 times until you try to understand what they're looking for. But sometimes we just, write whatever, and then without checking what the question is looking for. In this case, it says, determine the nature of the roots. In other words, I am not solving the equation. I'm determining the nature of the roots. If it is given that f of x is 3, so remember our equation was f at x, it's equals to 15 over x squared minus 4. But they're telling us now, we need to find the nature of the roots if that whole thing there, f at x, it's equals to 3. So which means that 3 will be equals to 15 over x squared minus 4. Then I can have an equation here. I can cross multiply. This times that will give me 3x squared. 3 times minus 4 will give me a negative 12. And 1 times 15 will give me a 15. So now, how am I going to get how am I going to get the nature of the roots? First, what do? I must arrange it in the form ax squared plus bx plus c. So I'll have 3x squared, 15 that side gives me 27 equals to 0. Why did I leave the gap? The 27 is negative. Now my problem is that we don't have the x. So I'm just going to put 0x here. So that I have the value of a, the value of b, and the value of c plus. Right? So if I then have my formula, I'm able now to substitute everything. So I'll have b squared, it's 0 squared, minus 4, my a is 3, my c is going to be negative 27. Right? If I use my calculator, then I get 243. Now, if I check 243, what do? I go to my calculator and then press square root of 243. Right? So I'll say square root of 243. If I get a decimal number, then it means it is not a perfect square. It is not 0. It's not a perfect square. So if it's not a perfect square, what type of roots am I going to have? They are going to be real. But if it's not a perfect square, then they become irrational. and obviously they will be unequal. I hope now you understand why the table is very important. Going to be 243, not a perfect square, but it's greater than 0, therefore it will be irrational. So the 4 marks there, we must be able to can get it if I'm given an equation, and they say without solving the equation, determine the nature of the roots. You see, I'm not solving for x here. I'm not solving for x. If I'm solving for x here, I was supposed to then start from here, I must go and solve for x. But here, this is how we find the nature of roots. Nature of roots. So that is the method of finding the nature of the roots. How do I get these 3? I go to my table. I must understand the table because I need to discuss those nature of the roots at the end of getting that question. Okay. Right. Now let's look at this again. Now here, this is the second part now. Now they say find the values. You see, remember the objective of the lesson is to say by the end of the lesson you must be able to determine the value of the variable given the nature of the roots. In this case, I'm given the nature of the, they say these roots will be equal. The only part when the roots are equal is that delta must be equals to 0. That's the only time when the roots will be equal. Now the equation is given, not a problem. Given the equation, nice equation that, first thing that I've asked myself, is that equation in standard form? Ax squared plus bx plus c equals to 0. Yes, an equation. So my work here is to first get the discriminant. So first I must get the discriminant. Delta equals to b squared minus 4ac. Substitute there. So my a here it's 1. My b it's k plus positive k. My c is plus 7. So now I'm going to come here and say, okay, I've got k as my b. I've got a which is 1. I've got c which is positive 7. Then I'm going to get k squared minus, if I multiply this, I think I'll get 28. But I'm not done because I need to find the values of k. So I'll come here and say, okay, 4 equal roots, because I'm given, that is given to me. That 4 equal roots, this delta must be equals to 0. If they told me that the roots are non-real, then my delta will be less than 0. If I'm given that the roots are real, my delta will be greater or equals to 0. In this case, they're saying the roots are equal. So then I'll say, because this is delta, I must put 0 there. So I'll get k squared minus 28 equals to 0. Then I solve for k. So k squared, I can transpose the 28 that side, take square root on both sides. So I'll have the square root of 28. Right? Now remember, with the square root of 28, I must have plus or minus. So the k will be equals to, I can just simplify this. I think it will be plus minus 2 root 7. So we'll have 2 values of k. So in other words, you can see there they trick you there. They said, find the value of values. So they want you to understand whether, I must check whether it's a value or values. In this case, it's values, it's 2 of them. It's plus 2 root 7 and minus 2 root 7. Those are the 2 answers that they're looking for. So the 5 marks also will be for substitution there and knowing that this should be in this, should give you there and equating that to 0, and then from there simplifying that and then also writing the 2 answers at the end. Okay. All right. Now, in this question here, which is a very interesting question, and there's things that we must always know, basic things that we must always know. First of all, writing in the form ax squared plus bx plus c. Look at how this question is structured. It's structured in such a way that you are able to can get the marks. Easy marks, collectible marks. Given 4x squared equals to 11x minus 3. First, ask yourself, is that in a form ax squared plus bx plus c? The answer is no. And look at what they give you here. That 1 mark, just to write it in standard form. You see? So first of all, let's write that in standard form to get the 1 mark. If this question is 3 marks and it's in a test, it's 3 marks. Once you know how to write in standard form, you already have 1 out of 3. So 1 out of 3 is 33%. You have already passed just by writing the standard form in that particular question. So in this case, we have 4x squared. I know that transposing sometimes is a problem. And we've been doing it from grade 8. Let's revisit that part and then let's understand it. So it's 4x squared. You cannot transpose that whole thing like that and say it's minus 11x minus 3. No. Transpose each term with its sign. This is a plus sign. So if I transpose it to that side, then it becomes what? Negative 11x. Then I transpose this one to this side, then it becomes plus 3 equals to 0. I've got my 1 mark out of 3. I already passed. Now the next question will say, determine the value of the discriminant. They're not telling you to get the nature of the roots. Can you see this word now? We've talked about this word, discriminant. What do? They give you that sign to show you that that is the discriminant. They even give you the formula to do it. Okay, so in this case, what I'm going to have, delta equals, I'm just substituting. I first need to know what is my A, what is my B, what is my C. So first of all, my B is negative 11. I must square it. Please, there is a difference between negative this and this. This one is going to be negative 121. This one is going to be 121. Can you see where we drop marks? Just by doing some silly mistakes. So when you're squaring when you're substituting and you must substitute by a negative number and there's a square. You need to write down the brackets and square it correctly and go to your calculators and you can be able to do that. If you go to your calculators now and say negative 11 squared, the answer that is going to give you is negative 121. But if I say open bracket negative 11, close bracket squared, the answer that I'm going to get there will be positive 121. So it makes a difference in your answers. Right? And then minus 4, open bracket. What is my A? It's 4. What is my C? It's 3. So we write it with that. We write them with their signs. So from here, you go to your calculator. Punch it as it is. And then from there, then the answer will be 73. Now, that is all. We are not discussing any roots. We're not discussing any nature of the roots. We are just getting the discriminant. So the 2 marks is for the substitution and the answer. Right. Now, if you go to the next one says, hence describe the nature of the roots. Now you see here, hence means use the answer that you got previously. You do not have to rewrite everything. You already know that your delta that you got there was 73. You just need to tell us what type of roots do you have. So you go to your table and check. Is 73 equals to 0? No. Is 73 greater than 0? Yes. Is 73 a perfect square? No. So therefore the roots are going to be real because it's a positive number. The roots, because it's not a perfect square, will be irrational. And if they're irrational, they're also unequal. That's what we need here. You see the marks. This examiner was a very good examiner because he was going to give you 1, 1, 1. This is 3. Right. Now, let's move to the next question. The next question, basically the same as the one that we have done on the K. Here we now need to find the value of B, or the values of B. Will the roots of that thing be real? First thing first, look at them. First thing first, what do? We need to first write this thing in its form, standard form. So in standard form, it is going to be 4x squared minus x minus b equals to 0. Then I know what is my a, what is my b, what is my c. So my a is 4, my b is minus 1, my b is minus 1, and then we have our c at minus b. Please don't confuse this b here with the b that we're here. Remember, b is a coefficient. In this case, the b is a constant. Okay, right. So now we're going to have delta equals to b squared minus 4ac. We are told that the roots, for which values would that be real, right? So for real roots, we know delta must be greater or equals to 0. Remember, real is 3 forms: real, equal, real irrational, equal, real rational, equal. So in this case, if they just say real, we combine the two signs, greater and equals to. Right. Now we're going to say, first I'm going to get my delta. So my delta is going to be, what will be the value of A there? Will be, so the value of B will be -1. Members, the brackets. Your A is going to be 4. My C is going to be -B. Then I'm going to add 1. Negative times negative is positive. 4 times 4 is 16 times B. Then I know for real roots, delta must be greater or equals to 0. So which means that whatever I got for delta there, I must say it is greater or equals to 0. So it's 1 plus 16b, it's greater or equals to 0. Then for me to get the value of b, I must transpose that 1 to that side and divide both sides by 16. So I'll have minus 1 over 16, right? So b will be greater or equals to minus 1 over 16. Let me just cancel out that one. All right. So how many values do you have? Can you see how they trick you there? And now I'm going to have one value of b, not one part, but these are values. Why am I saying these are values? It is because it is not one value. It is not one value. It's all the numbers that are less than minus 1 over, that are greater than minus 1 over 16. See, when I have a number line and I've got a 0 there, then the value there, minus 1 over 16, might be somewhere there. So I need all the values, including minus 1 over 16, that are greater than. So each and every value that is greater than that will give me real root. So that is what it means. In the previous one, k was supposed to be equals to, so there are two values. If I say b is greater or equals to, it's not one value. It is a lot of values. We can't write them here and finish today. So it's a lot of values. As I indicated on the number line there, every value. You can see minus 1 over 16, there's a 0, 1, 2, 3, 4, all those numbers. Between 0 and 1, we've got millions and millions of numbers, of fractions there. So all the values in there. So you can see it's 5 marks there. So then 5 marks there, the substitution, first the writing of this one into this, and the substitution, the answer there, for knowing that this is equals to that, and from there solving that equation. Okay, so a lot of marks, so please make sure we understand this part. Right, another one where we talk undefined, we talk real, and this mostly this question comes in this way. So we must also understand this part. See, the other one was 15 over, and this one now got square root. That part of the square root, I know it gives you a lot of problem, but after today, you must go and practice it. Let's look at how do we do it. First of all, it says, given m is equals to the square root of 25 minus 2x all over x. Let's say determine the value or the values of x for which m will be, first it must be undefined. Remember I said inside the square root, the negative answer that we get inside the square root does not mean that we are undefined. It does not mean that. The only part that we can know that is undefined will be when this value of x in the denominator is 0. If that is 0, then this whole fraction will be undefined. So we look at the denominator and check if the denominator, which number will give us a 0 on the denominator. So that x value, if it's 0, then the value is undefined. So that's just like 1 mark. So it's a 1 mark question. So the answer there that they need here is just x equals to 0. So the x equals to 0 will give us undefined. Okay, so it means that x must not be equal to 0. If it's equal to 0, then it gives us undefined. Now, 212 says, for which values of x will the m be real? So that whole thing must be a real number. Okay. So for it to be a real number, x must not be equal to 0. So meaning that the first thing there, x must not be equal to 0. Because if x equals to 0, then this whole thing cannot give us a real number. That's a restriction that we must know. The bottom part cannot be 0. So for it to be real, x must not be equal to 0. Okay. But now, let's look at what must be on top. Remember, we're talking to the values of x. So the values of x, for this to be real, the number that is inside the square root must be positive. Because if it is negative, then it gives us non-real. Interesting. So which means that the first part, the second part here is that, I'm just going to write this a bit. The second part will be saying 25 minus 2x must be greater or equals to 0. So for it to be real, what is inside the square root must be positive. So for it to be positive, it must be greater than 0. So what will be the values of x? Let's check. Minus 2x, transpose this, you get greater or equals to negative 25. But I know when I divide by negative, what happens? The sign changes, the inequality sign changes. So the x value will be less or equals to 25 over 2, which is 12,5. Right. So the value of x there should be less or equals to 12,5. So this x value can be less or equals to 20. And again, x must not be equals to 0. That's where I bring in that one. Because if x is 0, the we'll get a 25 on top. Square root of 25 is 5, it's fine. But if x is 0 there, we get undefined. So that must not be, we must include, because if I say x is less than 12,5, draw my number line here. My 12,5 might be here. So if I say x is less than, I'm including the 0 here, and I don't need that part. So it should be x is less than 12,5, but x is not equals to 0. It's very, 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 very important that you understand. If you understand this part, you will be able to get any question that comes that looks for the nature of the rules in terms of real, rational, equal, and all that. You will be able to do these questions. Right. The next question there says, without solving the equation, I love that, without solving the equation. When we say don't solve the equation, they say, please don't use that whole formula of minus b plus minus da 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 da. No, that formula we don't need. What do we need? We need only part of that formula. We need only the delta equals to b squared minus 4ac. This part here, this is what we need. My first question, is that in the standard form? Perfect. Yes, it's in standard form. Now, substitute. What is my A? What is my B? What is my C? What? So my B is negative 6. Remember this, the brackets. Minus 4. My A is 6. My C is 1. So which means I have 36 minus 24, which is 12. Three questions I ask myself. Is 12 positive? Yes. Is 12 a perfect square? No. What type of roots we have? Yeah. Not a perfect square, irrational, and unequal. Three things that I must write there. Why is it irrational? It is not a perfect square. Please don't write this in your exam. Okay, I'm just showing you that for it to be irrational, it must not be a perfect square. So it's real, irrational, and unequal. I hope you understand this part of work that we've done now. That the biggest thing that you need to understand is the table, and the table gives you the nature of the roots, looking at different answers that we get for delta. So we always going to use the discriminant, which is our delta. We must use that formula, which is the discriminant formula, to get the nature of the roots. That question, you have seen all these questions that are done are in question 2. So basically in question 2, that's where you can do that. Even in functions, they can ask this question in functions, because they say, what type of roots are you getting in this function? For instance, if I've got a graph like this, maybe a parabola graph, and therefore this graph here is like this, then from there it's a 2 here. What type of roots do I have there? Equal roots, because we only have one solution here, so it's equal roots. If I have a graph like this, then I have it like this, minus 1 and 2 here. I have 2 unequal roots, but these roots here, can you see these 2 values here? Right. So those 2 values here, those ones talk to rational numbers. Remember, if the roots are rational in this case. If I talk to this and I talk to this type of roots, for instance, here it's square root of minus square root of 2, and here maybe a square root of 3. I know these roots are irrational roots. So the roots are irrational, and then I talk to this one, whereby I can draw a graph like this. This graph does not touch the x-axis, so the roots are non-real. So this is just a quick summary on the graphs that you can get. These ones we say they are equal roots. This one we say they are irrational roots. And this one we say they are rational roots. All right, so the four, now you can see that summary, I've just summarized the table using the graphs. Equal roots, rational, which is still going to be real, irrational, which is real, and the non-real. Non-real means that graph is not going to touch the x-axis. In this case, it touches only one place, equal roots. This touches two places, but it is this will be a perfect square. It will be a perfect square then. And in this case here, it will be irrational roots. Okay, I think we're done with this part, with this section. That's about 5. Sometimes it's about 5 marks to 7 marks. So please check question papers and then let's do this question correct this year, please. All right, now let's look at the complex numbers. This we have done this year, beginning of the year. We're always doing this type of questions as revision because we know that it carries marks and it's an easy section that we can quickly get marks from. By the end of the lesson, you must be able to do the following. You must be able to know that this is the way complex numbers are written. You must know which one is the real part and which one is the imaginary part. We must be able to write the conjugate of this, and sometimes they love this question. Must be able to read the question and understand then what the conjugate is. Write down the imaginary numbers in this form. We must know that I squared is equals -1. Where I see I squared, then I replace it by -1. We must be able to can add, subtract, divide, and multiply complex numbers. We'll see one that I have in the next slides, where we divided, and let's see what to do when we divide. We must be able to represent this in an Argand diagram. That's very important here, because now if I'm given a complex number, I must be able to can know what is the reason for us to put it on an Argand diagram is to check also what our argument will be, because sometimes you find that the values are given, the A and the B are given, and we put them, we swap them around, and then our argument, which is an angle, becomes wrong. So determine the modulus and the argument that's what I was talking about. This is the R value here, and this is the angle that we're talking about in the next slide. Write this as a triangular or polar form of that complex numbers. We'll look at that also. And we solve equations with two complex numbers with two variables. Very important also on that. Right. Now, let's look at some of the quick notes that I've put in here. We are not going to ask you define a complex number, but you must just know that what is a complex number? What am I dealing with here? So I'm dealing with a real part, and I'm dealing with an imaginary part. A is the real part, B is the imaginary part. So if I write it as A plus BI, the A is the real part. When you do your Argand diagram, you'll see that this is the imaginary part and this is the real part, right? So if I've got A and B, so A being the real part and then B being the imaginary part, so the point is A and B, right? So if I've got that, right? Now, with a conjugate, we talked about this. What do we have as a conjugate? So the conjugate, we only change the sign of the imaginary part. Change the sign of the imaginary. Okay, very important. So here you see it's A plus BI. The conjugate will be A minus BI. Now, sometimes in the exam, they confuse you. They'll write BI minus A. I mean, you know that when I have an I, then I have got an imaginary. If there's no I, it's real. So meaning that I must change the sign. This is a plus sign. So the conjugate is got a bar on top there. So the conjugate will be plus BI minus A conjugate will be minus BI minus A. Never change the real part. Or you can just write it as minus A minus BI so that it looks this part. Okay. All right. In the next slide, the adding and the subtraction, very, very important. When you add and subtract, if I add the real parts together and the imaginary parts together. I cannot have A plus BI minus 2A plus 5I. I cannot add everything. And A plus BI minus 5 into A plus 8. No, no, no. The real parts will be added together and the imaginary parts will be added together. In this case, I just wanted to write maybe 5BI. Okay, so the real parts will be added together, the imaginary part added together. In other words, we are adding like terms that we always do, we have always done in the previous grades. So the A and the A will be added together, so I'll have minus A. The BI and that will be added together, so it will be 7 of them, isn't it? So I've added the real parts together and the imaginary part together. And these two cannot be, I cannot add these two because it's A is real, I cannot add imaginary and real parts. Subtraction is the same principle, add real parts and imaginary parts. When we multiply binary numbers, we must always have this in mind, that when I'm multiplying, for instance, 2A multiplied by 3, 2I multiplied by 3I, I must always have this in mind, because I'm going to get 6I squared. So once I get a square, then I know the I squared must be changed to minus 1. My answer will be negative 6. Only when I have I squared. Okay, right. We'll do a on the division part, because division we use conjugate. We'll do that when we're doing our activities. The next part here is the complex numbers represented in the Argand diagram. I've already talked about the Argand diagram. If I've got A plus BI, the A is positive, the B is positive, so that will be in the first quadrant. Now that R here, remember here we always work in a unit circle. So in a unit circle we have what we call R, which is the radius. The radius is from the center of the circle to the circle. So that's why we call it an R. Now we've got the x-axis and this arrow here. Now the amount of space formed between the x-axis and the R is called an angle. And that angle we call it in the language of complex numbers, we call it an argument. Not that argument that you always do at school. So the R here is the modulus. In this case, we're not going to call it the radius, we're going to call it the modulus. So the modulus is the R. Please, please, please make sure you understand the terminology. Right. Complex numbers, you write its own terminology. When you're practicing revising, write the terminology that you're going to be using here. You know, the Argand diagram, the modulus, the imaginary, you know, the modulus, all those, you know, the polar form, you know, all those things, you must know what they mean. Argument is the angle that is formed, the amount of space formed between the modulus and the x-axis or the real part. Okay. Right. Now, how do we solve complex equations with two variables? These are easy questions, easy marks that we must get. And I know you like complicating the questions, and you complicate the whole sum, and then I'm going to show you how easy these things are, how easy you're going to get the marks here. Now, their modulus, and that will be equal. So in other words, if two complex numbers are equal, therefore, remember the real parts here, so this is the complex, the imaginary parts. This should be the real parts. Here, the real part. So here it should be the A and the X. I think the arrow is moved there. Is the A and the X, which are going to be the real parts, and then the BI and the YI will be the imaginary. Will be the imaginary. All right. So now the A and the X will be equal because there are real parts on both sides. The BI and the YI will be equal because they are imaginary parts. Okay. So now the real part A will be equals to X, that's what I'm talking about, and the B will be equals to Y. Why did we remove the I? Because if I've got BI equals to YI, the I and the I can fall off. And then we can have the B being equals to Y, and that's what we're talking about. All right. Now, activity number one, complex numbers. These activities this is a very easy activity. First thing you must remember that the complex number will be written as A plus BI. This is the real part. This is the imaginary. Right. Now, when I'm given the complex number in that form, which one is the real part? Which one is the imaginary? Obviously, the real does not have an I, so it will be 4 with its sign is positive. The imaginary will be 3. That imaginary number is 3. Okay, because the I is the imaginary. Now, in this case, that one is quite easy. It's going to be 1 over 3. The other one will be minus 4 over 5. All right? On the third one, tricky one here, what should we do? We must divide those two. So in other words, I'm going to have minus 2 over 3 minus 5i over 3. Because that 3 there, it's for minus 2 and it's also for that. So which means that that will be minus 2 over 3. The other one will be negative 5 over 3. Right. What will be the next one? So with the next one, what do I know? 6i. I don't have the real part. No, I do, because that will be my real part. So my real part will be 0, because if I have 0 plus a number, then I don't write that 0. And the real part, the imaginary part will be a 6. You're not going to be asked a table like this and then where you have just to populate this. No, I'm saying this, it's important that especially when we come to this one, whereby you need to split it and write it as A plus BI, because they can ask you write this in the form A plus BI. You must be able to can write it properly here. Okay, sometimes you can be given something like this and then they need the argument. So you must be able to can get the argument or the modulus. Right. Now, this question, you might get it in question 1, whereby they say solve the following equation, but the roots, write your answers as complex roots. But please, when it is written like that, and then you see your answer should have you must use complex numbers to write down your answers. You must use the complex knowledge to write down your answers. Please don't say the answers are non-real. Because you have done complex numbers, you are technical math learners, you have done complex numbers. You can't say your roots are non-real. Those are the math learners that can say that, but you as technical math learners and you have done complex numbers, you can't say that. Let's look at this. So in this case, I'm going to use the quadratic formula, whereby my A value will be 1, my B value is 0, my C value is 4. So I'm going to substitute. My B value is 0, plus minus the square root of, I'm not going to write down the formula, 0 squared minus 4 times 1 times 4, all over 2 into 1. Okay, now if I work that one out, I'm going to get plus minus the square root of negative 16 all over 2. Don't use a calculator as a technical math learner to get the negative square root of 16. You will not get it. Square root of negative 16, you'll get an error. And then you put an error in your answer sheet. No. You know, in complex numbers that we've done also in grade 10. So you know that you have to split that and write the square root of 16 times the square root of negative 1 all over 2. Yes, because this is a 0, I'm not going to write that 0 there. So in this case, what do you get? You are going to get x equals to plus minus, what is the square root of 4? Square root of, 16 is 4. But we know that the negative 1 is the same as the I squared. So instead of writing minus 1, we write I squared. And the square root of I squared is I. Then all divided by 2. So your answers are going to be plus minus 4i all over 2, which is the same as plus minus 2i. So you'll have two answers. You'll have plus 2i and minus 2i. And that's what you're going to get. You can substitute that in there, you'll get a 0. If I can just quickly do that, I substitute in by plus 2i, so it's 2i all squared plus 4. So I want to see what I'll get. So I'll get 4i squared plus 4. Then the I squared is negative 1. 4 times negative 1 is minus 4. Minus 4 plus 4 is 0, which equals to the right-hand side, which equals to that. So in this case, I'm able to then solve for that. Okay, so if you get this question in question 1, you must be able to do it, whereby you are again going to get a square root, a negative inside the square root, and you must be able to again work it out. Now, in the second one is the same principle. So when I substitute, I'm going to substitute that now. So I'm going to have a 4 squared plus minus the square root of 4 squared minus 4 into 1 into 7. 2 into 1. So obviously I'm going to get the negative inside the square root. So not sorry, there's not 4 squared, it's 4. Right? So I'm going to get negative inside the square root, and I'm going to get a negative 4 here. So I'm going to get a negative 4 plus minus the square root of negative 12 all over 2. Then my two answers are going to be, if I work that one out, I'm going to get, I think it's minus 4 plus minus 2i square root of 3 all over 2. Then my final answer will be minus 2 plus minus this I the square root of 3. Okay, because the 2 will divide into that. Take out the common factor and I'll get these two answers. You can see I've got two answers. Minus 2 plus I 3 and minus 2 minus I root 3. You can substitute this in there, in the values of x, and then you're going to get a 0. That you can do on your own. Okay. So complex numbers are just quite very, very, very easy. In this case, you're given z1. Now, 8 minus I, and you're asked to write down the equation of z2, the conjugate of z1. Quite easy. So you're just going to write z2 here, because they told you it's z2. They didn't say it is z1 bar. Don't write any bar. It's z2. It's called z2. They say z2 is the conjugate of z1. So z2 will be equals to, what do we do, by the way? We change the sign of the imaginary. So it will be 8 plus I. Done. 322 is quite very easy. I'm not going to waste time here. The answer will be negative 1 I squared. Can you see how this is how simple these questions are? That's how they ask them in an exam. Right, so please know that. Already we've got 2 marks, which are quite straightforward and easy marks. I've taken this from past papers. Now simplify z2 over z1. Yes, that's, and you must write it in that form. You see? Now, what do you do here? That's where you use the conjugate. So z2, we know, we already have it. It's 8 plus I. z1, it's 8 minus I. Now, how do I write it in this form? That's why I use the conjugate. So what is the, I multiply by the conjugate of the denominator. So 8 minus I is the denominator. The conjugate is 8 plus I. 8 plus I. You see, it's the same as multiplying by 1, because I can cancel out those 2. We'll get a 1. So now I'm going to have, multiply those 2 top. Don't cancel out that because we're going back there. I'm going to multiply the top ones. So I'm going to get 64 plus 16I plus I squared, all divided by. The bottom one is the difference of 2 squares. So it's 64 minus I squared. By the way, we know what is I squared. It's negative 1. So this thing here is going to be negative 1. This is going to be negative 1. Okay. So here I'm going to have 64 minus 1, which is going to be 63 plus 16I. Then I'm going to have 64 minus into minus 1, because this negative is not the same as that negative. So negative and negative is positive, so I'm going to have 65. Why do we do that? So that we eliminate the imaginary in my denominator, because I know that I'm going to get I squared there, which is negative 1. But how do I write it in this form? So do you still remember on that table? We split the 2. So it becomes 63 over 65 plus 16 over 65 I. So it is in the form A plus BI. Right, and this question was 4 marks. No, I put marks in there. Right. Okay. Now, in the next question here, that is the question that I was talking about, which is straightforward, easy, straightforward. What you need to do is just to multiply out the bracket. That's all that we do. So here I'm going to say x minus yi equals to I minus, multiply this for I, negative, positive, negative 8. Okay, then you just write down, I prefer, okay, this I think we can be able to can add here. I'm going to get negative 3i. All right, and then minus 8. Okay, so that's x minus yi. So what I need to do here, the simple thing to do here is just to equate the real part and the imaginary part. Look at this. I prefer to draw a line here and say the x value here will be equals to the real part, which is 8. Remember, I multiply this, got 4i, then I multiply that, then this 1i minus 4i will give us that. So therefore the x value will be equals to -8. The y value, I'm going to write it as it is. Minus y, it's equals to -3. So my y value will be equals to 3. Those are the two x values. Solve for x and y. So this is the same. That will be the same. Why did I put the y, the I in there? Because they will cancel each other. Okay, so that is why they will divide each other and then we'll get a 1. So these are the two values of x and y. All right. Now, given the complex number, remember this is a plus bi. Very important that I write it down. The most important thing to do is to put this on an Argand diagram. This is the imaginary, this is the real. Which means that this one is the real. So the real is a positive value, so it will be the square root of 2. Yeah. The imaginary is -1. So meaning that if it's -1, it will be somewhere there, -1. So my vector will be there, right? So it will be square root of 2 and -1. It's very important. That will help you to get the argument. Because now remember now my argument is that angle here. It is not any other angle in the first quadrant of that. Now, the first question says determine the value of the modulus. So the modulus is r. So it's r, it's equals to the square root of a squared plus b squared. So therefore that will going to be the square root of my a is square root of 2 or squared. My b is -1 squared. So the answer that I get there will be square root of, this is 4 plus 1, so that should be 5. No, that will be square root of that, yes. So it will be the square root of that, so it will be 2 and 2 cancel out. The square root and the 2 will cancel out, and then from there we'll have a 2. 2 plus 1 will give us a 3. So that will be square root of 3, not 5. So hence, now I've got the r. Hence, express this in polar form. Give the angle in degrees. Very important that sometimes we give the angles in radians and instead of degrees. So what do we do for the modulus? So I'm going to say the tan of theta first because I need the angle. Tan of theta will be equals to, remember it's b over a. So my b is -1 over a, which is square root of 2. So to get the angle, I'll have the reference angle first, which is 35,3. Now, that angle that I got, it's a reference angle. Why? It is because I've got a negative here. Now, I must first check. That is why I said it was important for me to do that. That we don't say it's a negative and then we use the trigonometry thing to say if it's negative, then we say 180 minus. No, we must draw an Argand diagram. Once I've drawn that, I'm able to can check, oh, that angle is in the fourth quadrant. Therefore, my angle will be 360 minus that value, which is 324.7 degrees. That is the angle that I'm going to use. Then I'm going to say, now my z is going to be, remember the formula, it's r into cos theta plus I sin theta. So my r is square root of 3. The cos of the angle, I take 324.7 plus I, the sine of the same angle, 324.7. That's it. So that is in polar form. So the polar form needs degrees, and these angles are in degrees. Sometimes they write down in radians. So therefore it means you must change the angle to radians, which I hope we all know how to do. Okay. Quite easy one also. This one is straightforward. I've got pi and I've got q minus 3I. Quite easy, 2 marks. So we just need the answers. So the q value, this is the real. I prefer writing that as real on this side, imaginary on the other side. So I just equate them. Imaginary, it's p. That side is minus 3. So I'm done. That's the final answer. On the real, this is 2. On the other side, the real is q. So q equals to 2. So I'm done with that answer. Simple, straightforward. We don't have to complicate things here. All right. Now, the next one, you can see that I've left the numbering as it is so that then I show you that these are the questions that where you get them in the question paper. It's where question 3, that's where you get your complex numbers. Right, with this one, it's the same principle. What are we going to do there? We just multiply out the bracket, so it's p minus qi equals to 3 plus 8 plus 6i. So I can just add the numbers, so it will be 11 plus qi, 6i, p minus qi, then just equate p equals to 11, and the other one on the other side, minus q equals to 6, and then q will be equals to negative 6. And that is done. Okay. All right. Now, here's another scenario here. The complex number is given, and the modulus is given. Now we need to find, and I'm told it's in the third quadrant, meaning that I can draw my Argand diagram. It's in the third quadrant. I know that this is 2 root 2, and this point here, it's going to be k n minus 2. See? So it means that in this, I need the value of k. So I need to use that formula. R equals the square root of a squared plus b squared. But in this case, what should I do? I know what is R. So I'm going to write my R as this, because it's my modulus. And then that will be equals to the k squared. I'm going to write that one is squared and remove that squared. Right? And therefore my A is going to be k squared. Then I've got minus 2. So if I work this one out, my k will be plus or minus square root of 4, and k is equals to plus minus 2. But in this case here, I can see k cannot be 2. So k must be equals to, therefore, my k will be equals to negative 2. I'll choose this one. The reason is, it is in the third quadrant, I'm told. Therefore, the k value will be negative 2. And it says, hence express this in this form. In this form, we need the angle. How do we get the angle? How do I get the angle? So it will be the tangent of theta. It's in the third quadrant, I don't have a problem. So it's minus 2 over 2. Remember, it's the y value over the x value. You must write it like that. Because if I write tan theta equals to 1, 1 will give me 45. But I know that the tangent here will give me 45 degrees as a reference angle. But then it's in the third quadrant, which is 180 degrees plus theta. So the theta will be 180 plus 45, which gives me 225. And therefore, I want it in this form. The R value is 2 root 2 and says 225. So that is how they want it. They want it in that form, and we must put it in that particular form. Okay, with this one, the principle, remember what we do here is the conjugate. So it will be x plus yi equals to 2 plus 3i all over 1 minus I times. So the right hand side we multiplied by 1 plus I over 1 plus I, the conjugate. So therefore, multiply the top, I'm going to get 2 plus 5i plus I squared all over. Difference of two squares, 1 minus I squared. Okay, so on top there I'm going to get, this is minus 1, that's minus 1. So I'll get 1 plus 5I all over 2. Because this is minus 1. 1 minus minus 1 will give us 2. So the x plus yi, I still keep it, please. So in this case, remember, split 5 over 2i, x plus I, real to real, imaginary to imaginary, x is half, and y is 5 over 2. And those are the two final answers. 6 marks, not a problem. You must just know how to multiply binomials. Remember how to multiply binomials. There's 2i, this is 3i, that's 5i. That's where I got the 5i. Okay. Right. Now I'm given this complex numbers in this form. Remember, it is r cis theta. This is an angle. This is the argument. Let's use the correct language there. This is the argument, and this is the modulus. Now they say write down the argument in degrees. Oh, that is what I was talking about. The modulus now is in radians. Now we must write it in degrees. So we'll say pi over 3. How do I change radians to degrees? Remember, it's an angle. So remember, I don't want the pi, so I must divide by pi. I don't want the pi. Just let it divide. On top, I'll put 180 degrees. So I'll put 180 degrees over pi. If I want to change degrees to radians, I put the degrees at the bottom, pi on top. So in this case here, my angle will now be equals to the pi cancels out. 3 into 180 goes 60 times, so the angle there will be 60. Now I know that the angle is 60 degrees. I can be able to work out whatever they want using the angle of 60 degrees. Okay? So if they want me to write down in this, write down the argument in degrees, that's what they want. If they wanted me to write down write it in the form a plus b I, then what will I do? I'm going to put this one in polar form, put this one in polar form, and then from there I'm able to write it in degrees. Right. Write z in the rectangular form. How do I write z in rectangular form? Here. So that is in this form. So remember, we've got a 2 and I've got 60 degrees. So I want to write it in rectangular form. And they give it to you there. So that is what I was talking about. So it will be 2 into the cos of 60 degrees plus I sine of 60 degrees. Right? So I'll go 2 multiplied by cos 60 degrees. It will give me a 1. Right. So meaning that I'll have, remember this is z. So this multiplied by that will give me a 1. And then from there I'll say 2 multiplied by sine of 60 degrees. Then I'll get square root of 3. So meaning that this one will be plus square root of 3i. So this is in the form a plus bi. So first I must write it in this form, and then the degrees I have at 60, that one was 2, so that is the easy question to write. So for P and Q, same principle, remove the brackets. Don't remove them, multiply them please. You have 2qi minus 3qi squared equals to 5 minus 14i. So now I'm going to have plus P2QI. This will give me, this is going to be minus 1. So minus 1 times this will give me plus 3Q. Remember the I squared is now gone. Now what do we do here? First, let me deal with P. P will be equals to, can you see P? P is real, this is real, this is real. So P plus 3Q, it's equals to 5. Now let's look at the Q, at the other one, at the imaginary. So the imaginary will be 2Q, it's equals to negative 14. Now can you see I've got simultaneous equation? Nice one, I love this. I cannot solve for P and Q in one sum, so what should I do? I can see that I've got one variable. Q will be equals to negative 14 divided by 2. So Q will be negative 7. So once I got this, I can go this side and say, I know what Q is. And then from there, I'll have P equals to 5 plus 21, which is going to be 26. Right, am I right? So that will be minus 7. There's 21 there. So and then I transpose that, then I'm going to have it as do I have? It's plus 2Q there, so that's fine, yes. So that will be 26 and minus 7. You can check my calculation there. The procedure is right. You can just check my calculation, but I think I'm correct. Okay. Right. In this next one, write down the conjugate of Z. First, I must split it. I must have minus 3 over 3 plus 6i over 3. So I'll have negative 1 plus 2i. But then they said we must get a conjugate of that. So it will be minus 1 minus 2i. As simple as that. Okay. Right. Now the next question will say express this in polar form. So polar form, first, what do? I know that this one is going to be minus 1 plus 2i. I go and draw a Gann diagram. This is A, this is B. So A is real, so it's minus 1. That one is imaginary, it's minus 2. So my vector is there. So it's in the second quadrant. I can then check my angle will be in the second quadrant, 180 minus. So therefore, I'll get first I must get my R. So it will be minus 1 squared plus 2 squared, which will give me square root of 5. That's my R, my modulus. I cannot get it in polar form if I don't have my modulus and my argument. So now my argument will be the tan of theta, it's equals to 2 over 1, negative 1. So therefore, I'm going to get my angle here is 63, I think 63.43 degrees, which is my reference angle. Then my angle will be 180 minus that will give me 116.57. So for me to write this in polar form, I need the square root of 5. I need the cos of 116.6. I'll just put it correct 1 decimal. Plus I, which is sine of 116.6 degrees. That is in polar form. And it is in the second quadrant. Can you see why we say this is very, very, very important? The Gann diagram is very, very, very important when doing this type of questions, especially when you're looking for the polar form which needs an argument. So you must draw a Gann diagram so that they can get where that angle is. It's not always going to be 180 minus. It will be 180 minus, 180 plus, depending on where your complex number is. Okay. All right, the last question here. These questions are like 5 marks, 6 marks, 4 marks. So please make sure that you understand this. So there I have x plus yi. What I need to do is to multiply out that, multiply out the brackets. So if I multiply out the brackets, I'll get 6i plus 4 minus 3i squared minus 2i. Right? So now here, I already know that the square will give a negative 1. So I'll have 6i minus that will give me 4i. Then I'll have plus 4 minus plus 3, because that will give me a negative 1. So I'll get 4i, I think, plus 7. Because the 4, it's positive, which is fine. And then from there we have this one is 4 plus 3, because that one will give me a positive, and then keep the x plus yi, keep the x plus yi, and the x value will be 7, and my y value will be 4, and these are the two xy values. Okay, the next lesson will be on the 6th of August 2025 from 2:30 to 4 o'clock. Topic will be the revision. We are revising for the prelim, and the topic there will be differential calculus. And I thank you.